I got 3.
All right, so got our supplies, binder, pencil, calculator, handout. If you're missing your bell ringer, I will let you know several of them got thrown out yesterday because they were left in my room.
What? Oh my.
You leave your stuff. I'm just going to start throwing it out. The binder collection in the back of the room is getting obnoxious. So get your stuff, put it in your backpack, and take it with you. All right? I'm literally running out of room to hold on to things, okay? I've got several people's books. I don't know how they're studying, but their grades, their own. So let's go to bell ringer. We want to simplify the expression. Since there's no variables, this is an order of operations question. So what will we do first? Kirsten? Correct. We are going to do what is in parentheses first. Now, there's multiple things going on in the parentheses. So what would we do first? And how would we know? Ren? Why are you going to divide? Because it's on the left or because it's division?
Whatever that is.
Yeah, the PEMDAS.
Because of PEMDAS, we would have to do the division first. Okay? So 27 divided by 3, Ren? 9. And 9 plus 6?
15.
Thank you, Cameron. So we have 2 to the 3rd power minus 1/3 times 15. What is next in our solving of this problem, Ann?
The exponent.
The exponent. And what is 2 to the 3rd power?
8.
8. 2 times 2 times 2. So we have 8 minus 1/3 times 15. Okay? And what is the next step to solving this? You know? All right, Manir.
15 over 1 and times that, or you can do 15 divided by 3.
Okay, so you're finding the multiplication, the 1/3 of 15?
Yeah.
All right, and what is 1/3 of 15?
That's 5.
1/3 of 15 is 5. You are correct. So we have 8. Maybe I should write with a pen. 8 minus 5 for a final answer of?
3.
3. Very good. Fabulous. Wonderful. All right, second bell ringer. We have a diver, and he was 120 feet below sea level. What integer represents the diver's current location of 120 feet below sea level? Millie?
Negative 120.
-120. Okay, it said he ascended. What is ascending? Going up. So we're going to increase where he's at. But then it says that he ascended for 10 seconds at a constant speed of 1/2 foot per second. Well, how would we figure out 10 seconds at a constant speed of 1/2 foot per second? That's a rate. Kind of some stuff we've been working on. You know, 1/2 foot per second would be a unit rate. Colby?
So
So every second, well, if he goes 1/2 foot every second for 10 seconds, he goes 5 foot.
Okay, so what math problem is that you just solved?
10 times 1/2.
Very good. Okay, so we have our expression that he starts at -120, and we're increasing it with our rate. Colby already told us that 1/2 of the 10 is 5. So if he starts at -120 and he ascends 5 feet, where is his new location? Noel?
Negative 115.
-115 feet. Explain that to me, but not using the word negative. Oh. Explain it to me, but do not use the word negative. Kate?
115 feet under below sea level?
115 feet below sea level. Very good. All right, so put your bell ringers in your binders so they don't become part of the disappearance in the abyss.
Your backpack.
It'll end up in Munir's backpack and we'll never see it again. Be tragic. And we're going to be working on the packet that you picked up. And if people are at home or watching or listening to this, it's also linked on Canvas. So if you lose yours, you'll have to download and print.
In the school computer?
I don't know. You'll just have to do it.
I have a printer.
I try not to make too many
Oh
extra
my,
copies
oh
and
my.
waste paper.
I saw a cellular device.
Okay, here we go. Before we get started on our lesson today,
Yeah, should have done that a long time ago.
before we get started, I want us to kind of break down everything you remember about K. The stuff that we've just been working on.
Tupelo.
I want to know all these little things about K. I'm so glad your voice is coming up on this because it'll be real interesting to explain. All right, tell me one thing, Ontario.
It's the constant of proportionality.
Okay. It is the constant of proportionality.
It's sticky over here.
All right. Okay, stop.
There's like
Please.
syrup.
Yes, I will get you a wipe in a minute. Please stop. All right, give me something else, Colin. Okay, we use the ratio y over x. Very good. Something else. Colby?
You multiply it by x and you get y.
Okay. In order to find y, we multiply the k times the x. All right. Anything else we can remember? Lacey?
When x is 1, y equals k.
Ooh, good one. In our coordinates, if x is 1, then the y value is k. Clara?
Never mind. It's
No.
a variable.
K is a variable. There we go. I like it.
I was thinking about independent, dependent variables, but that would be y.
Can it
What-
be?
Y depends on x. Okay, that's something to keep in mind is the y depends on the x. It's good for our word problems. Think in terms, because what we're going to be doing today, we need to switch over to this way. What about the graph? When we're dealing with K and constant of proportionality, proportional relationships, tell me about the graph. Tell me one thing, Lucy.
It has to start at the origin.
Okay, it must run through the origin. And, Millie?
Need to connect it up. Needs to be a straight line.
Okay, it does need to be a straight line. Okay. Now, when we've been doing these, and I want us to focus on the graph now, okay? We have the origin, which is 0, 0. Every time we looked at our graph, if it was proportional, it ran through 0, 0, and it had to be a straight line. We good with that? I think we've beaten this into everybody's head pretty good. Okay. Well, when we're graph, we spent our time in quadrant 1.
Are we gonna have to do more than quadrant one?
Oh, I'm so glad you asked that. Yes.
Is there quadrant 6?
No, 4 quadrants. Quad, 4.
Oh,
There's 4.
you're talking about like the
Yeah.
negative x.
We're fixing to get to there. Okay, their questions and their comments are literally leading to where we're going to with this. Okay? The green line that I have on here hits the origin, it's a straight line, and it has a K, correct? Can we agree with this?
Yeah.
Cameron, can you agree with that?
Yes.
I can agree with that. Okay, but as was just brought up, Colby brought it up, Munir brought it up, with the coordinate plane, it isn't just the one quadrant. We have 4 quadrants. We have a positive y, a positive x, but there's also a negative y and a negative x. Okay? We still have the origin hanging out in the center where they cross. All right. Now, just like my green line a minute ago, if it runs at that origin and it's a straight line, we have K. But there's now 4 other quadrants. Do I have to run my line through the origin?
Yes.
No. And this is where we're going to have to shift our thinking a little bit. K is a straight line that hits the origin. But here in pink, I have given you a straight line. It's, for all intensive purposes, nobody get on a level or anything. It's a straight line, correct? So it's linear, just like the green one, but it doesn't hit the origin. So what's the variable? M.
Does that mean?
We're going to explain it. All right. The way first and second we kind of threw it together was K and M are like cousins. Okay? They're related, but they're not the same. All right? In this case, they're related because they're both straight lines. They have to be on a straight line. But they also tell me how the line is changing. When we did K, you did Y over X, correct, Clara? Are you sure? Do you have any idea what I just said?
If we do K, then it's Y over X.
And does the Y over X work for any point on the line?
I mean, yeah.
Yeah, if the points are on the line, they should have the same Y over X value, correct? Okay. Any point on a line should also give you the same M. Okay? What's the key difference between K and M?
K runs to the origin, M doesn't.
There's your difference.
Yeah.
K runs through the origin, M does not. But this is where we're going to be practicing today, is looking at how to find the M, and we're going to keep relating it back to the K so we don't forget the K. The concept of M is going to follow you into 8th grade math, and it's also going to follow you into algebra, possibly some geometry, and algebra 2. So it's not going anywhere, okay?
Yeah, I'm not
So
going
we started with K, now we're going to the cousin of M.
I always wondered with the slope.
All right,
Because they had those at, like, on the white DC days.
Am I M?
so slope. I like this picture because, has anybody in here gone skiing? I can't say I have because I'm afraid to die.
I love skiing on black.
Okay, all right, so question. If we use, all right, reel it back in. If we use the term slope and we think it in terms of skiing,
I think of slanted.
you think of slanted. All right, so if you're getting on, if I'm going to get on the slopes and I am going to go skiing, I am terrified. I've never skied before. Do I want a steep slope or a not steep slope? Oh, no. I'm afraid to break my leg, die, my neck.
And not. Wait, have you been watching?
Yeah, I want the bunny slopes. I want with the little kids. Okay.
Have you been water skiing?
Time out. We're recording. Bring it back. Okay. When we're talking about the slope of the line, just like skiing, you're talking about how steep it is. Okay? But when you ski, you're going down the hill, right? So that's a negative because you're going down. Well, in order to go down, you had to do what?
Go up.
Yeah, you had to go up. Usually, you take your, you take the
What if
ski
I'm on a
lift.
higher mountain?
All right. Now, it goes further than just the concept of skiing. The question is why do we always have to understand math? What is the point of this? When will I ever use this? Slope is used in construction. If you get into building a house, your architects and your builders have to understand slope because they have to understand the pitch of a roof. Because your roof goes up one way, down the other, and comes to that point. Well, if that's not done right, you're going to have a lot of structural issues. But also, So the steepness of your roof, the pitch of the roof is a concept of slope. The steepness of your ski slopes, same idea. Truckers have to understand it. This is a common road sign, especially when you get up into the hillier areas up in the mountains. What is it telling, especially the truckers? Did I tell you?
It's a steep road ahead.
They're letting them know that there's a steep road ahead. Okay? Truckers have to know this. If it's a very steep road, what's gravity going to do to the speed of the truck?
It's gonna flip it.
It's going to accelerate that truck, which means it's going to take longer for that truck to stop. Okay? So your truckers have to understand this. I mean, never really thought about that.
They've got a bunch more weight.
They do. They have a lot more weight to have to stop, and the steeper the road, the longer it takes for them to stop that truck. Okay? And if you're the one driving the car, you also need to pay attention to that, because the last thing you want to do is slam on your brakes
Yeah,
and have a truck behind you.
Yeah, you're gonna flip, I think.
All right? Truckers also have to understand if there's a percentage on there, because that percentage is letting the truckers know exactly how that road is changing.
About 7 Sorry.
If it's a bigger percentage, is that going to be harder to stop or lower to stop?
Lower.
Harder to stop.
harder.
It's a steeper. I think
Yeah,
you said
yeah.
steeper.
Cause like 100 feet, like
Mhm.
straight, and then it's so far from 7. So yeah.
Yeah.
It changes a lot.
So
That part.
this really does, I mean, it does pertain to things outside of just your textbook at this point.
Can it go negative?
Yes, slope can be negative.
Would it be like -8 degrees, so you'd be going in?
No, you be going straight.
I don't know. I think what they would do instead is they would just shift the sign. Truckers have enough to worry about. I don't think they want to have to worry about positives and negatives, so they would just shift the sign and let them know that they're going up. Instead of the truck going down, it would go up.
So
Yeah.
negative slope would go like.
Negative slope is like going down the ski slopes.
Oh wait, so they just.
We're going to look at some.
So negative is down. Can I use direction?
No.
All right, so let's go into our notes.
A slope.
All right, Cameron, the steepness of a line. What is it called?
But we just learned.
Yeah, it's called the slope.
Pay attention.
Yeah, the slope. That's what I say.
It's how steep that line is. How much does that line shift? How sharp has it been tilted? Okay? And yes, it can run up, it can run down.
Okay, it's so shiny.
But one thing I want you to keep in mind with your lines, if you want to mark yourself a little note, we read lines just like you read books from left to right. Okay? They give us 3 lines. Which one has the biggest slope? Lawson. Jay, why does the third one have a bigger slope? And you're just looking at it visually. I don't have any numbers. It's more tilted up. I mean, we can look at it. I like to think of these as like a hill. If I want to go and roll down that hill really fast, I want the biggest slope in that hill. Well, which one am I going to go the fastest down?
The third one.
Yeah, that first one is what I'm going to ski on.
Ooh, that'd be so.
Yeah, probably even probably even flatter.
Yeah, take the magic card.
I rolled in poison ivy once. I didn't even know.
All right, reverse. Okay, Noelle, what is the letter we use for slope? M. And everybody always wants to know the Y's behind the letters. The M comes from their French word. The K for constant of proportionality comes from a German word. I Googled that this morning because I had to know. Shh, time out.
Where's me and Cameron?
Millie?
Constant, there's a C and not a K, and there's a K after the spell.
Put it.
Well, in German, it starts with a K. It's word for it. And then it gives you the French word meaning to rise or climb, which is why we use the M.
There you go.
Are we good, you two?
Yes.
quit, please. Okay, we're going to add some things to our notes as well. Now, when we have the K, and this is where we're going to start seeing some of this stuff tie together, okay? If we're going to find K, what's our ratio? Y over X. All right. Off to the one side, I want us to draw a little coordinate plane. Now, where does Y go on the coordinate plane? Ontario?
The top of the middle line.
Okay, so Y runs in what direction?
Up and down.
Y is going to run up and down. And which direction is the K going to run, SJ? Side to side. All right, so Y is going to run top to bottom. X is going to run side to side. I'm pulling the K into here just to kind of see where they're still connected, okay? So our Y is up and down. In slope, we call that the rise. Okay, so the Y runs up and down. We call that the rise. You can't rise left to right, okay? You rise up. Now, your X runs left to right, and with slope, we call that the run. Rise over run. What this is telling us is that when we're looking for the slope, we're looking at how did the Y change? So how did it go up or down? And then how did the X change? How did it move from left to right? What? I'm going to explain it because what we're going to do is we're going to use some graphs, and out of those graphs, you're going to find me the slope by using rise over run.
What's our test on?
You're going to take a small quiz Friday. Oh yeah, but it'll be an easy way to end the week. I promise.
Is there a rating on it?
Okay, we're going to this. We'll talk more about the quiz another day. All right. I'm going to increase this and then kind of switch back and forth. All right. We're going to find the slope of a graph of a line. Now notice, if this was constant of proportionality, if I said find the K, you would look on your line, you would find me a point, you would do Y over X, and you would have your answer, correct? Easy, easy. Well, that's because it runs through 0, 0. I only need 1 point and I can find my K. Slope doesn't run through 0, 0. I need 2 points. Okay? K uses 1 point. M uses 2 points. All right? That's our first thing. So on your graph, on that line, I want you to choose any 2 points that you can tell me the coordinates on. We're not all going to use the same ones, okay? So I want us to pick our own numbers. I'm going to put mine up there later, okay? Pick 2 points on the graph, specific, like you know the numbers to it. No guessing.
That's on the line.
Well, it has to be. On your paper.
Oh.
On your paper, because we're all going to have different points so that we can make a point in just a minute. No pun intended on that. That's okay. But it's related to yesterday's homework. Yeah, come with a dad joke.
We had homework.
7th period did that. I've heard lots of great dad jokes today.
We did it in class.
I have homework passed for you.
Oh, no dad joke for me?
Oh, I got a dad joke.
Was it on entry last?
You got a dad joke?
Yeah.
All right, give me a dad joke, Ontario. Shh.
Why did the...
Shh.
It was something about a turkey. I don't remember.
I got a joke.
All right.
Oh. Yeah, have you ever heard of the movie Constipated?
Continue.
What?
Have you?
No.
Because it never came out.
Oh Lord. Okay. All right. We'll do more jokes in a minute. I think Noelle just ended class on that one. Okay. Emery, tell me one of your points that you picked. Say that one more time, babe. If I go 2, -1, you told me your point was right here. I'm getting particular here.
Oh, does it have to be in that
Shh. The point has to be on the line.
one?
Has to be on the line. Millie, give me 1 point.
I put 2-0.
2-0 would work. Over 2, but don't raise up or down. Okay? I want somebody who did not use that point to give me another one. Lacey. 4-1. That would work. Okay, y'all keep your stuff to you. Okay, I'm going to use these 2 points. That's why I picked it from 2 different people. If you have 2 different points, leave them. Okay, there's a connection we need to see here. That's why I want everybody doing their own thing on this one. All right. If I go back over to my notes side real quick, we want to start from the left point. We're going to start from the left point. Okay. We're going to be doing the ratio rise over run. The first thing we have to do is we need to find the rise or the fall. Okay? I'm either going to go up or I'm going to go down. If I go up, that's the rise, and that means it's positive. If I go down, that is considered a fall, and I have a negative number. Now, for this class, to keep things consistent, okay, and consistency is really good for some people in this room, we're going to do the rise or fall and then run to the right, okay? So we're going to go left to right on the graph. It'll make sense in a minute, okay? What some people are going to do is they're going to find their own way to do it, and that's fine, but they're going to have to keep some other factors in mind, okay? All right, so back to our graph.
Have you seen Medear's driving skills?
Back to our graph. What is the ratio in R's for slope? Colby,
Like in the one.
in our words.
Run.
2 R words.
That's hard.
Rise and run. Rise over run.
Okay, rise over run. All right. Now for my color-coded minded people, I'm going to do my rise in pink and my run in green. Now, I'm going to start at my leftmost dot. And everybody should have to go up to get to the right dot. For me, I only have to move 1 place up. Some of you may have to go 2 or 3 or 4 places to get up to the same level as the other dot. Hint, we're drawing triangles, by the way. So my rise, based on these 2 points, is a 1. Who has a different rise? Okay, Lucy, what do you have?
4.
A 4?
How do we know what rise is?
Jatalia?
From your lowest left.
You have a 3.
Your lowest left.
Millie?
Rise?
You have a 3, Clara? You have a 2, Noelle?
6. I'm saying 4.
A 4.
How are you
Okay.
I said never mind.
What is that?
Okay, so to recap, the first thing we do is we go to our left dot. We're either going to have to go up to the next dot or we're going to have to go down to the next dot. This one we went up. And then we're going to do the run. I have to get over to the dot. I had to run 2 places. You notice I'm counting my boxes. I'm not counting lines. Something to keep in mind. Now, I have the fraction 1/2. Jatalia, what fraction do you have? You have 3/6. Colin, what do you have?
4/8.
4/8. Clara, what do you have?
What about the negatives? Like,
You shouldn't have any negatives.
but I did my dot over in the negative.
You start in the left one.
We always start on the left.
Where's the left?
Colby,
2/4.
you have 2/4. Okay. 3/6, 4/8, 2/4. All of them equal 1/2.
So rise and run.
That's the reason we can use any set of numbers here, or points. Because if you do your math right, if you count your rise and count your run right, every one of them will simplify to the proper thing. Okay? What it's telling me, if I started back here at this point, at -4, -3, my slope is telling me that if I go up 1 and over 2, I'll hit my line. And it keeps working. Up 1, over 2, I've hit my line again. Up 1, over 2. So if I had to extend my graph, I could do that just by following the same pattern. Go up, go over, go up, go over. I create basically stair steps up my line.
So it's going to be the same thing the whole time.
The whole time. And even if I decided to go up 2/4, well, up 2/4 still puts me on my line.
Whoa.
It's the same fraction.
It's a lot easier than it sounds like.
That's the bottom part of what they've given you over here. All the different types of graphs that you could have gotten are on that bottom. I did the one in green using the 2 points that I asked for. Colby, yours would have looked like the one in orange. 3 out of 6 would have been the one in purple, and then Colin, yours would have been the one in red.
What about 50 out of 100?
Well, if your graph was big enough to go up 50 over 100. So every one, as we've already proven, goes back to a slope of 1/2. At no point will you use decimals or mixed numbers when we deal with slope.
Will you ever use negative?
Yes, we will use negatives. We're going to use some in a minute.
Okay.
Noelle, question.
So I did, my point was in the negative section.
That's fine, but you still had to go up and over to get to the next point.
But mine looked like that.
Well, that's fine. How many did you go up?
4.
How many did you go over?
Oh.
8. 4/8 is 1/2. Clara,
I was just confused. Mine was 2/4.
up 2/4. 2/4 is 1/2.
I was confused about it in the negative section.
Oh my god.
But that's what she just brought up.
I know.
Yeah. It's not the numbers that you're starting with, it's the directions that you're moving. Okay? All right, let's go to the back of that. We're going to practice finding the slopes of some lines.
How would it be negative if you start on the left and you're always going to go up?
Not always going to go up and over. We're going to see that with the first one we do.
Oh, because it's going downhill. So you're going to go
And we're going to look at the visual part of this tomorrow. All right, we're on the back of the first page. I blew this up just so that we can see it a little bit better. Now, in order to do slope, what is the ratio in R's that we're going to use. Ontario.
Rise over run.
Rise over run. Beautiful. Now, before I can do anything, what do I need to have on my graph? 2 points. Any 2 points as long as you know the numbers. So you pick your 2 points. I am going to pick Munir. Tell me 1 point on this line.
Pick 2 until
I got. Oh, I got. So any point of the.
Yep, as long as you can tell me the exact numbers. You don't want something that is floating between 2 bars.
-4 and 4.
-4 would be above the line. -4 would be on the line.
What? I'm looking down there.
Well, that would be positive and then negative.
Yeah.
Lawson, give me another point, please.
Oh, my fault, my fault.
Um, no, -3, 1. If you notice, if I go over -3 and up to 1, it actually is sitting slightly below the line. So when you're going down your line, you need to find it where it's hitting exactly in an XY grid part. Does that kind of make sense? Colin? 0, -1 would work. Okay. So those are my 2 points. If your 2 points are different, keep them, and let's see if we get the same results. All right, first thing I need to do is I need to do my rise. But Colby, what do you notice if I start with my left dot?
It's on top of the other.
Yeah, am I going to rise or fall? Yeah, this one I'm going to have to fall, which means my number is not going to be positive. It is going to be a negative. Well, how many boxes did I move? 3. I can count my boxes by ones because everything's marked in ones. So my rise was actually a fall, and I'm going to put -3. And now I'm going to do my run. So we'll keep it green. So starting there, I need to run over to my dot. Oop, that's not green. And how far did I run? I ran over 4.
Would you do -4?
No.
Because then it would be positive.
Think about the coordinate plane or just number lines in general. If I go up or to the right, I'm positive. If I go left or down, I'm negative. So since I went down, that's negative. To the right, it's positive. Things to keep in mind if you go other directions on these. Noelle.
Why is the numerator like a negative?
Because instead of I had to go down to get to my point.
Why do you start that point and not start the one? You have to start at the left.
I'm just keeping it consistent.
She can.
Wait, you start the one right?
I can technically start at whatever one I want to start at. Okay? But in order to do that, we have to remember positive and negative directions. Okay? So just to show people that it really doesn't matter, let me erase these real quick.
So it would basically be the same thing. if
Okay,
you started
let's
from the right.
let's watch. If I start at the right, I'm going to go up 3, correct? So up is positive. So that would give me a +3. But then I would have to go to the left 4. Left on a number line is negative.
So you could
So it's still one negative inside that fraction, which makes the whole thing negative.
wait. So anything like quadrant
It has nothing to do with quadrants. It's completely what direction you're moving.
Oh, so the bottom left and the top left are negative.
Bottom and left go negative. Up and right go positive.
Oh.
That's why I said for right now in class, let's just always start with the left dot.
Oh, I started with the right.
But here's another thing. Tomorrow when you come in, the first thing we're going to do is what I like to call slope man. I'll explain to him. But it's a way that when you look at the line, you can immediately tell if it's positive or negative. Okay? And then that way, if you can automatically tell positive, negative, then you can just focus on the counting of the numbers. Okay? Question?
So, like, if the line is planted that way, it's always going to have a negative.
Yes. We're going to look at that tomorrow. Jay? Yeah, go on. All right, let's go to the next one. All right, I'm still doing rise over run, but now I just need to find my what? I need my 2 points. So you find your 2 points. Colin, question, or do you have points for me? You got a point for me? All right, give me a point. -1, -3. That is a good point. No, I'm going to go to somebody else who did not use -1, -1, -3. Lucy? 1, 5. There we go. Okay. Now, I'm going to start on the left, and I'm going to have to move up or down.
Wait, is that? I got one.
I'm going to move up. Start at my left dot. Yeah, if it's confusing you, draw your triangle. Do you notice every one of these, we end up drawing a right triangle? Yeah. If you just draw your triangle, I think you'll kind of be on a little bit kind of a more step-by-step thing for you to see. The triangle. Okay, so let's look at the rise. I need to count from the bottom to the top the height of that triangle. Noelle?
8, 2.
8, 2. 2, 3, 4, 5, 6. All right. So I have a rise of 8, a run of 2, but I do have to reduce my fractions, and it can come out to be an integer. That is allowed. Colin? 4 over 1 or just 4. You can state slope to be an integer, but never forget that the 1 is underneath it. Okay? As if I had to extend my graph and I said, okay, the slope is 4. We have to know, okay, I'm going up 4 over 1. We can't forget that over part. Oh, you want to do the next one?
Yes.
Oh, sure.
Yes, got it.
I got it.
Got it.
Oh, bro.
All right.
Who can tell me a point on this?
Can I do this?
Hold up a second. All right. Munir, since you're going to teach class, I'm going to pause the recording because what you put up there won't come up on the screen. So I think we've got pretty good questions and answers here for everybody at home.